Hi everyone, you are welcome to this session. In this session, we are going to be looking at a very important but tricky and corny topic, which is standard form. Yes, standard form. It is popular amongst the junior secondary classes, JSS1, JSS2, JSS3, majorly JSS2 and 3. Yes. So this topic is very simple, very easy, very simple. There are just two things that you have to master for you to be done with this topic. But if you miss those two things, I'm telling you, just a silly mistake, a little mistake can lead you to the wrong answer. So as simple as it is, for you to get it right, you have to focus, keep your attention 100% on me and the board so that you don't lose the important part of this lesson. Is that taken? Now, what is standard form? What is standard form? Standard forms, most times it is often referred to as scientific notation. What did I call it? Scientific notation. So standard form is a kind of a way of expressing a very huge amount of number or very little amount of number. Get the information. It's a way of expressing what? Either a very big number or a very small number in a much more easier way using the powers of 10. Do you get the explanation? I'll take it once again. Standard form is a way of expressing a huge amount of number or a very small amount of number in a much more easier way, making use of the power of 10. Now, there are some keywords that you're supposed to understand there. Very huge amount of number or very little. If a number is too big, for you to write it is going to be difficult. For example, I ask you to write 1 trillion naira. You write your naira sign and you start writing 1 trillion. You are going to see that you are going to write so many zeros before you write trillions. This is a very huge number. In fact, some number you have to write it is going to go across this board. Remember, numbers are written in infinity. You can start a number from 1, 2, 3 till infinity. So which means definitely there are very huge amount of numbers which we cannot easily write. The same thing, there are some numbers that are very small. Very small. So that is why it is often referred to as what? Scientific notation, because it is mostly used by scientists, especially for those of you offering basic science, hoping to be a scientist in the future. You have heard of how scientists measure the distance between the sun and the earth. A very huge amount of number. They have to reduce it into what? Standard form. The same thing, still in that science aspect, you discover that when you are dealing with microorganisms, there are organisms that are very small. In fact, you cannot see them with your naked eyes, and they are called microorganisms. These organisms are so small, for you to talk about their size, you cannot use ordinary number or the centimeter, decimeter. Sometimes you use millimeter and you even use standard form. So all this I'm saying is kind of weird because not all teachers are going to tell you the explanation, the meaning of standard form before jumping into calculation. So the major reason why we use standard form is why when a number is too huge or very little, we use standard form to write this number in a much easier way, making use of the powers of 10. Making use of the powers of 10. Now, remember I told you that for you to be perfect in this topic, there are two things you have to know. You have to be perfect with two things. The moment you understand those two things very well, standard form is a walkover for you. One of those two things are powers of 10. And the other one is decimal points. Don't think you can see from there. So these are the two major things. The key important consideration you should put your focus and your attention on for you to be successful in solving this kind of questions that deal with standard form. You have to understand what powers of 10 are, how powers of 10 operate, and you also have to know about decimal points a lot. So for me to explain these two things, I'm going to need space. Therefore, let me clean the board. So here are the major problems that we can have in this topic. Make sure you listen attentively to what I'm going to be showing you. It can really get confusing if you are not focused. Let's talk about the powers of 10. Now, what is the meaning of power? What is the meaning of power? Not this power. No. What is the meaning of power? In mathematics, power is used to represent how many times a number is being multiplied by itself. So if you multiply a number by itself, that means that number has been raised to a power, but you don't know what power. The moment you multiply a number by itself, you have raised that number to a power. For example, 2 multiplied by itself, you have raised 2 to a power, but we don't know what power. 4 multiplied by 4, we have raised 4 multiplied by 4, we have raised 4 to a power. Which power did we raise it to? We don't know. Let's say we now have maybe 5 multiplied by 5 multiplied by 5. We have raised 5 to a power. Let me say 8 multiplied by 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 8. You see, we are multiplying these numbers by themselves. The moment you are multiplying a number by itself, you are already raising that number to a power. So now, what is the power we have raised these numbers to? The powers we have raised them to. How many times did we multiply this number by themselves? For the 2, we multiplied them how many times? 1, 2. Therefore, we say this is 2 raised to the power of 2. How many times did we multiply 4 by itself? We count 1, 2. Therefore, this is 4 raised to the power of 2. How many times did we multiply 5 by itself? Count it. 1, 2, 3. Therefore, it's 5 raised to the power of 3. How many times did we multiply 8 by itself? 1, 2, 3, 4, 5, 6. Therefore, we say this is 8 raised to the power of 6. Raised to the power of 6. That means we have multiplied 8 by itself 6 times. So if I should tell you that I have 3 raised to the power of 9, what does it mean? Yes, say it. It means we have multiplied 3 by itself 9 times. That means we have did 3 multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3, continuously until it gets to 9. This is 1, 2, 3, 4, 5. I'll continue. 6 times 3 times 3 times 3. You getting it? This is what power talks about. So now when we say powers of 10, it means the powers of 10. That means remember we have 10 raised to power 1, which is just 10. Happy? We'll have 10 raised to power 2, which is what? Multiply 10 by itself 2 times, which is 10 times 10. So 10 raised to power 3 will means what? Multiply 10 by itself 3 times, which is 10 times 10 times 10. You getting it? Continuously like that. So these are the powers of 10. Did you follow me up to this point? If you did, that means you have finished. In fact, you have successfully mastered half of what you need. Now, what is left now is for us to know about the decimal points. If you are fully sure of yourself that you have understood what the powers of 10 means, that means you are 50% qualified to solve standard form questions. First thing is to understand what the powers of 10 are. Power is a way of representing a number by multiplying it by itself. You multiply the number by itself consecutively, and then you count how many times you've multiplied that number, and then it's going to be the power. So powers of 10, we have 10 raised to the power of 1, 10 raised to the power of 2, 10 raised to the power of 3, 10 raised to the power of 4, 10 raised to the power of 5, continuously till infinity. So powers of 10. Remember, our standard form says we express huge numbers or small numbers in a much easier way using the powers of 10. Using the powers of 10. Let's continue. Now let's see what are decimals. We all know what decimal point is. Right from primary school, you see a number 2.1, right? 3.158, 28.92. All these points you are seeing are what we call decimal points. But there are other things you should know about decimal points. Yes. When you see an ordinary number like 24, it has a decimal point. It has, yes. Don't tell me it doesn't have. It has a decimal point. Where is the decimal point? The decimal point comes immediately after the last number. Although most times it is invisible, we don't write it because it's useless. So if you see an ordinary number like 24, just know that there is an invisible decimal point there and other zeros at the back. The zeros are infinity. So if you see something like 124, just know that not just 124, there is a decimal point immediately after the last number. Are you getting it? So this is the major thing you should know about decimal points. You need to know where your decimal point is, even if it is not being shown. Are you getting it? So you should be able to count from 1 to 10 using decimals. Let's say from 1 you get 1.1, 1.2, 1.3, 1.4, until you get to 2, then 2.1, continuously. So this is what you should know about decimal points. If successfully you understood what we have covered so far, then I congratulate you in advance, because whatever questions you are going to be solving on standard form is going to be so simple for you. Cheers in advance. Let me wipe the board so that we can start solving questions. Here we go in this calculation session. In this calculation session, we have actually done the preliminary and the foundational work we need to do. All you just have to do now is listen to the steps to follow when we have questions to solve. Now, the two different types of questions or problems we'll be solving is conversion. Yes, conversion. We won't be doing operation in this class. We're going to be doing conversions. How do we convert huge amount of numbers or little amount of numbers into standard form? And how do we convert that standard form back into the huge amount of number, or the standard form back into the small amount of numbers? These are the two things we'll be looking at in this class. Yes, in this class. Now, before we do that, there are some key things I still have to put you through on. The first thing is that when you are converting those huge numbers to standard form, or those small numbers to standard form, what do we do with the multiples of 10? We make sure that we multiply a number by the multiple of 10. We will look for a number that we can multiply it by to get that number. You might be confused what I'm talking about. For example, if we want to convert this number, are you seeing this number? This is what? 3, 4, 5, 6, 7. When you pronounce this number, you get what? 10 million in digits. I can easily write this as 10 raised to power 7. 1 multiplied by 10 raised to power 7, instead of writing this long number. Because when we multiply this, we are going to get this number. So what they are trying to say now is that write something that when you multiply, you will get that number. For example, instead of writing 500, I now told you to just write 5 multiplied by 100. Remember, 5 multiplied by 100 is still 500. It's still the same thing. So we have just expressed 500 in this form. But in standard form, it must be a power of 10. That is the first criterion. when you want to convert a number to standard form? Your answer is going to be what? Times 10. For sure, you don't have anything to do. It must be times 10. Then you start looking for, what can I multiply by this number to get that number? And how do you get it? It's very, very easy. That is where the decimal point comes in. You start moving your decimals either to the left or to the right. Okay, you can either be moving your decimals to the left like this, or you are moving it to the right like this, depending on the needs. Depending. Now, when you are multiplying these numbers, the number you are going to use to multiply that power of 10, it must not be smaller than 1. And that number must not be bigger than 9. It must not be up to 10, I mean. It must not be smaller than 1, and it must not be up to 10. So the number you are going to multiply by the power of 10, it can be 1, 2, 3, 4, 5, up to 9.9, but it must not be 10 and above. So standard form, when you convert a number to standard form, your answer is going to be a 1-digit number. Yes, it's going to be what? A 1-digit number. You know what 1 digit means? 1-digit number. It must not be up to 2 digits. Your answer is going to be a 1-digit number multiplied by the power of 10. So you are going to look for the 1-digit number, and you're also going to look for the power of 10. So let's practicalize what I'm telling you. Now the question says we should convert 243,100 to standard form. What is going to be our answer? First of all, you have to identify your decimal point. Where is your decimal point? If you remember you told me you have actually followed me till the end of the previous theoretical aspect. Now is the calculation. Where is our decimal point? Can you see it? I told you something about invisible decimal point that comes immediately at the end of every ordinary number. Yes, the decimal point is here. It's there. It's there at the end. Now, remember, we are looking for what? A number. Let me write it well. We are looking for a number multiplied by 10 raised to the power of another number that we don't know. So first of all, we have to look for this a. What number? How do we look for it? We are going to move this decimal point. Here now we have to move the decimal point to the left. We are moving the decimal point to the left. Now when we are moving the decimal point, you check. When we move it this place, 1, if the decimal point is here, how are you going to pronounce this number? You are going to pronounce it as what? 24,310.0. And that number is bigger than 10 now. Remember I told you that this a must not be bigger than 10, and it must not be smaller than 1. Therefore, we continue moving it. I'm going to move the point here again, and here I'm now going to be having 2,431. It's still bigger than 10. I'm going to move the point here. It's now going to be 243.100. 243 is still bigger than 10. So I'll keep moving. I'll still move it here. Now I'll now have 24.31. 24 is still bigger than 3. Now I'm going to move it here. And now it's now 2 points. You see, 2 points. Now 2 is not smaller than 1, and 2 is not bigger it's not big enough to compare it with 10. So 2 is not up to 10, and it's not smaller than 1. Therefore, our a is going to be what? 2, and our point is now here. It's now going to be 2.431. Now these remaining zeros are useless. Yes, but you can leave it to avoid confusion. You can still leave it. It's the same. So 2.43100, that is our a. Okay. Our times will come here, our 10 will still come. It's remaining this n that is on top here, which is the power of 10. Which power of 10 are we going to use? Now, we have been able to move our point until the number has changed to a number that is what? Smaller than 10 and not smaller than 1. Just one digit number. We need only one digit number before the point. So you are going to take your point from wherever the point is and keep it in a place where there will be one digit after the point. So after you do that now, for you to know the power of your 10, you are going to count how many times have you moved the point. How many times did we move it? Let's count. 1, 2, 3, 4, 5. Therefore, our power is going to be what? 5. And as simple as this, you have gotten your answer. You have just converted this number here to standard form. So the first step is what? Let's just take a brief review because what we just did might seem a little complex. So it's very important that we take a review of what we did. The first thing we do when we see the question is what? To identify our point. Let us know where is our point. Where is our point? And here we discovered that our point was at the end. Yes, it was at the end. Then after that, the next thing is to start moving the point to make sure that this A that we are going to replace, the number must be smaller than 10. Yes, the number should not be up to 10 and it should not be smaller than 1. And as we are moving it, we'll keep checking until we get to 2 points. That is when the number is now within the range between 1 and 10. We can now use the number. So all we do is we write the number, but we don't put the point here again. We have brought our point that was here. We have brought the point. Now multiplication and 10 raised to the power of what? The n. And for you to know the n, all you do is you just count how many times you have moved the point. And here we have moved it 5 times. So that 5 is going to be positive because it moved to the left. You can even add direction like this. To the left so that you don't forget. Because the second example we are going to be doing is going to move to the right. Look at the example. And this example says convert 0.00436 to standard form. We are going to follow the same step. The first thing we do is we identify our point. We have 0.00436, right? And then you write your formula. A multiplied by 10 raised to the power of n. Now, where is our point? This one is visible. We can see our point. Our point is here. Our point is here. Now, this is 0.00. So this number is smaller than 1. 0 is smaller than 1. So we cannot use 0 point because it is smaller than 1. So we have to move this point until we get a number that is bigger than 0, that is up to 1. And that number must be smaller than 10. So remember in the first case, we were moving to the left. This time around, we are going to be moving to the right to get that number. We are going to move once. And if the point is here, it's still going to be 0 points. So we still have to move it again. 2. It will still be 0 points. It is when we now move it here, that is when we now have what? 4.36. Are you seeing what I'm talking about? Here you now have 4.36. Now this 4 now is what? Smaller than 10. And it is up to 1. It's smaller than 10. So you don't have to move it again because if you move it again to this place, it's going to be 43.6. And 43 is going to be bigger than 10. So we are not moving it anymore. We are going to stop here at this 4. So our A now, that was 2.43100 here. In this case, is going to be 4.36. The A will now be what? 4.36 multiplied by 10. And the n, how many times? Remember the n means what? How many times you have moved your point. Now the end, how many times did we move the point? Let's count. 1, 2, 3. And we moved it to the right. So when you move it to the right, it's not going to just be 3, like this one that was just 5. When you move to the right, your answer is going to be in negative. So instead of 3, it's going to be in what? -3. Take note of that. This is something very, very cunning. If you don't put the minus, you fail totally. So if you move to the left, just write your power the way it is. But if you move to the right, you write your power with negative. Is this taken? These are two different examples. The first step to follow is what? Identify decimal. Okay? Identify your decimal. Then move it. Move to make sure that what? Number is between 1 and 10. Are you getting it? And then the final one, if you move to right, use negative, which is minus. And if you should move to the left, then use positive, which is the normal number. So this video, you can actually watch it, rewatch it. If you are having challenge, because you might have challenge, you can feel free to ask questions on this. It is very simple if you follow the steps that you have been shown. Identify your points, move your points. Okay, if you move it to the left, your power is going to be in what? Positive. If you move to the right, the power is going to be in negative. Now this is how you convert from a very huge amount of number or from a very little amount of number into standard form. Now let me put down questions where we have to convert from the standard form back to the huge amount, or from the standard form back to the real numbers again. I'm going to be wiping this. Yes, let's look at how do we convert from standard form to original form. Remember, this is just like opposite. We are going backward now. So this is like a common sense situation. When you see a number like this, you should know what has happened. Let me write down the number. Solution: 2.314 multiplied by 10 raised to power 5 is equal to, yes, when you see raised to power 5, what does it mean? It means this number, the original form, they're asking you to write down the original form. How do you think the original form of this number will look? Remember, when you move to the left, you use positive. And when you move to the right, you use negative. So if this number here is positive, that means it has been moved to the left. Are you getting what I'm saying? If it is positive, it means it has been moved to the left 5 times for us to get this number. It has been moved to the left 5 times. So for you to get your answer, you are going to move it to the front 5 times. You are going backward. Are you getting what I'm saying? That means this number, instead of 2.314, this 2.314, this point has been moved backward 5 times. That is why it was here. So we have to move it back to where it was before. 1, 2, 3, 4, 5. You have to move it back to where it was before. So the point is somewhere here. Yes, somewhere here. So we have 2, 3, 1, 4. What is here? What is here? Nothing. Nothing in numbers. In mathematics, nothing means 0. Therefore, we have 2, 3, 1, 4, 0, 0. Are you getting it? This is the original number that was converted to this standard form. Now look at what I'm saying about what I'm talking about. When you want to convert this original number to standard form now, the point is here. You are going to move the point how many times? 1, 2, 3, 4, 5 to get 2.314 5 times. That is why they got this. So you just have to sit down and look at it and say, okay, if this is positive 5, that means this number has been moved to the left already. I want to take it back to how it was before. Remember, you are converting it back to its original form. You are going to take it backward again 5 times to how it was before. Are you getting it? So that is how we got this number. This one is just mind game. You don't even need to calculate anything. You just have to use your head. Now, when you see this one, 2.61, let me write it down. 2.61 multiplied by 10 raised to the power minus 7. When you see minus, what does it mean? It means this number, this 2.61, what does it mean? It means it has been moved to the front, to the right hand side. That is why the standard form is reading minus 7. Remember when I told you, if it is what to the right hand side, you use negative, minus. So when you are seeing it now, that means it has been moved to the right hand side. So for you to take it back to where it is now, that means you are going to move it to the left hand side. How many times? 7 times. So you are going to move this to the left 7 times. Let me show you a practical example here. This is 2.61, right? Our decimal point is here. We are moving it back to where it was. Remember, it was moved forward 7 times before. Now we are going to move it back to where it was, to its original form, 7 times. So we are going to have 1, 2, 3, 4, 5, 6, 7, and the point will be here. Remember, what is here? Nothing. And nothing means 0. That means all this place is going to be 0, 0, 0, 0, 0, 0. And your answer is going to be what? Remember, before this point too, there is also a 0. Therefore, your answer is going to be 0 point, how many zeros? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then 2, 6, 1. This was the original number. This is the original form of the number. So when they were converting this number to standard form, they moved this number forward to make sure that the number is up to 1 and it is not more than 10. So they moved it 1, 2, 3, 4, 5, 6, 7 before they got this 2.61. And they used negative 7 because they moved it to the front. So for us to get our own answer back now to its original form, we are going to move it to the back. So these are the two major things that we are supposed to learn. How to convert to standard form and how to convert from standard form. It's supposed to be very, very simple if we followed everything. Yes. If you are confused at any point of this lesson from the beginning till now, you must have been jotting down your challenges. You can easily reach out to me and then we'll see what we can do about that. Is that taken? Thank you very much. See you in the next class. Bye.